Sorry about this thing. Yeah, so the other object is moving in this way. So whenever we want to calculate the velocity of B relative to velocity of A, right? So remember, this is relative motion in two dimensions, right? This is relative motion in two dimensions. The objects are moving in two different directions, right, in a plane. And in the earlier case, when we were calculating the relative motion in one dimension, so one object was moving in this way, and the other object was moving maybe in this way or maybe in this. So these were the velocities, right, Rishita? So all these velocities were in one dimension, not in two dimensions. But now we have all these velocities in two dimensions. Okay. So then velocity of B with respect to A. So velocity of B relative to A. This would be simply VB minus right. And we are doing the vector calculation, right? So remember, how did we do this subtraction of vector? These are two vectors and we are subtracting them, right? Right, Rishita? So yeah, so if we have two vectors, let's say this is A vector, this is B vector, and we are subtracting A minus B. So what did we do in that case? For the subtraction, what did we do? Do you remember? Yeah, do you remember, Rishita? For the subtraction of the vector, when we were doing subtraction. So if I want to find A plus B, that is the resultant, right? And this resultant I got using the parallelograms law. So let's say this is theta. I draw a parallel B in this side, parallel A in this side, and then and I connected the diagonal. So this was A plus B, right? But I'm not talking about the resultant. Now I am talking about the subtraction of the vectors. So for the subtraction case, what did we do? We elongated this B in the opposite direction. So yeah, so this was minus B, right, Rishita?
Yes, so it'll be A plus minus B.
Yeah, absolutely right. Good, good. So very good. So now when we use the parallelogram law, then we will get A minus B, right? So this is what we will do in this case. Whenever we will talk about the relative motion, so then what would be this magnitude? So magnitude of A minus B was A square plus B square minus 2AB cos theta, where this theta was angle between A and B, right? So keeping all those things in our mind, so we have to calculate VB minus VA, right? So VB is VA is this, and let's say this is perpendicular direction. This is V, right? So we have to calculate VB minus VA, which means that we have to elongate A or B.
A.
A, right? So we have to take the opposite direction of, right? So this would be minus VA, and then we take the resultant. So this would be, let's say this one and this one. So this would be B minus, right? So this was the idea of relative motion. And if I want to calculate, so relative motion of B with respect to A, this would be VB minus VA. And if I want to calculate relative motion of A with respect to B, then this would be VA minus V. Then I have to elongate this one. So then I'll have to elongate this one. This would be minus of VB, and then this would be a VA minus right. So this was the idea, or this is the idea of a relative motion in two dimensions. Okay, is this
Yes,
clear?
sir.
Yeah. And then, so let us do two or three questions, and then we'll go to. So on the basis of that, we have three kinds of problem in relative motion. So one is river crossing problem, right? River crossing problem. So remember, in this scenario, we don't use the relative motion idea. We use the resultant idea, right? Because in river crossing problem, so there is this river which is flowing, right? And then there is this man which is crossing that river, right? So in river crossing problem, we use result. And in the second case, for the case of the rain man problem, we use this idea of relative motion. Okay, and for the case of this wind problem, again we use this idea of resultant. So this thing is very important. In the case of rain man problem, we only use this relative motion. Whenever the two objects are moving, right? So whenever two objects are moving, we use this Rayman problem. Whenever we use this, so when we use one object is moving and the others are at rest, so then we use this resultant type. Okay, yeah. So we will do all these problems in this section, but let us do first the relative, and then we'll get back to this idea of river problem and all this. So river crossing problem, then rainman problem, and then wind problem. So all these kind. Okay. So this 70th question. The captain of a ship A traveling with velocity VA, right? So we have a ship, right? Ship A which is traveling with 3I minus velocity. So let's say VA is 3I minus, so this is in one dimension, we should write it in two dimension. So let's say this is 3I minus, right? And then we have a second ship B appears to have a velocity. So a ship B appears to have a velocity, right? So we are measuring this velocity of B with respect to what? So this is what is given in this case. Is this velocity of B which is given, or velocity of B with respect to A, relative velocity? Which velocity is given in this case? We know that VA is this much. Okay, so a second ship B appears to have this velocity. So this is what kind of velocity which is given? Relative velocity or velocity of B? Yes, Rishita. So just see the example of the train, right? So let's say two trains are crossing each other. So other one would be appear to be fast. So that is not the actual speed. The actual speed is different, but it is appearing, which means that that is the relative velocity, right? So this thing which is given, this is the velocity of B appearing from A, right? We are measuring the velocity of B with respect to A. So then this is 5A plus 12J. Is this part clear, Rishita? Yes, Rishita, is this clear? Your voice is very faint. Yeah, yeah. So your voice is very low. I cannot hear you properly. Can you?
1 second, I'll join through a different device.
Yeah, yeah. Of course, of course. Yeah. Please join. Hey, so yeah.
So can you hear me now?
Yes. Now you are crystal.
Yes,
So,
sir. I joined through my laptop and this is my iPad, sir.
oh yeah, yeah. Oh, good. Now, is this part clear to you? Because a second shift B appears, which means that this is the relative velocity we are talking about, right? So the relative velocity of B with respect to A. Clear?
Yes, sir.
Yeah. So now, what is this relative velocity of B with respect to A? That we already know. So that is VB minus VA. Correct?
Yes, sir.
And in the question, this is what we have to find out, right? So let us put all these values. So this is 5 I, right? And plus 12J, and this is VB and minus of 3I minus 4J. Then this is 5I plus 12J VB minus 3I plus 4J. So this will go in the left hand side and this will become VB will become 5I plus 12J plus 3I minus 4J. So 5 plus 3, 8I and plus 8 kilometer per hour. So this is the actual speed of ship B, right? But it is appearing that it is moving with this much of velocity because both the objects are moving, right? So yeah, and that happens due to this relative velocity. Okay, any doubt in this question?
No, sir.
Please note it down, and in the meanwhile, let me should check the score. What is the score? Whenever you have noted it down, please tell me. Yeah, whenever you have noted it down, I have to stay.
Done, sir.
Okay, so now let us do the next. Question. Okay, so this a car A moves due not at a speed of 40 kilometer per hour, right? So we have this not, right? So this is the velocity of the car A, which is 40 kilometer per hour. And then we have this is 40 kilometer per hour. And then we have another car B moves due east, right? So this is north, south, west, and so another car is moving at 30 kilometers. So this is BP, and this is 30 kilometer per hour, right? Now find the velocity of car A, car B relative to car A. So we have to find out VBA, right?
Yes, sir.
So which means that this would be VB minus of V, right? And we know that we have to take the negative of this, right? This is VA, so this would be minus of VA, right? Right, and then we take,
Yes.
yeah, so this is 40, and then we take the result, right? So let's say this is theta, right? This is 40, this is 30, so how much this would be? This would be how much? You have a triangle which is going like, right? So this one, and this. And this is theta, right? This is perpendicular, this is 40, this is 30. So how much would be this, Rishita?
So 30 by 40.
30 by, no, this magnitude. Just remember the
Oh, okay. Root of 30 square plus 40 square.
so VBA magnitude would be, uh, or if I don't write the notations, right? So then this would be root of 30 square plus 40 square. Root of, so this would be 50 square, right? So which means 50. So this is 50 now, right? And all the angles are in tan, right? So magnitude we have calculated. Magnitude is 50 kilometer per hour, right? Now we have to find out this tan theta. So what would be tan theta?
40 by 30.
Yeah, so this should be 40 by 30. So why this no? So east of south, right? This is in the north, and this is in the east, right? And we are calculating velocity of car B relative to A. So this would be downwards, and this is third theta, right? Okay, so this is theta, which is 4 by 3. Or if I take this theta, right, with the vertical, because this answer is not there. Theta is 4 by 3 with south of east this would be, right? So now let us calculate this. So if we calculate this theta, right? This is also with this angle with vertical, right? So now this would be how much? Perpendicular is 30, right? And base is 40. So this would be 30 by 40. So theta would be, this will cancel, and tan inverse 3 by 4, right? And direction is how much? Direction is east of south, right? When we calculated this angle, when we calculated this angle, so this was south of east, right? This angle is south of east. Is that clear? Right? We are in the east
Yes, sir.
direction. We are in the east direction and we are going south. But all these angles are given in east of south. So we are in the south direction and then we have to go east, right? So east of south. So this angle is east of south, right? East of south. So this is east of south. Okay. And if we calculate the other angle, so that would be south of east. So depending upon the uh, options, we have to calculate those angles, right? So which is the correct one? This one. Did you understand this part?
Yes, sir.
Yeah. So please note it down and then we'll do the next question. Yeah. Whenever you need me to scroll down the screen, please.
Sir, can you scroll down?
This was the angle. This was the angle that we will calculate. So this was 3, this was 4, this was 5, and this was the angle that we will calculate. So tan theta is perpendicular. This is 30, right? So tan theta is perpendicular by this. Noted, Rishita?
Yes, sir.
Now, let us do this thing again and that. Okay, so this is just an argument problem that a person standing on a moving truck throws a stone vertically up relative to himself, right? So we have this truck, right? And a person is moving in this truck, right? So we have this person and this truck is moving, right? And a person throws a stone in this truck. So to a person standing on the ground, the stone appears to move immediately after being. So let's say for this person, this stone will go and then it will come down for this person, right? But for a person which is outside of this truck, right? We will see that this truck is moving and then this stone is moving in this direction. So we have two velocities, right? So then this truck will move like in this, right? Is that clear? So relative velocity would be in this way, right? If we calculate the relative velocity, so that would be we have to take in this direction. So this would be in this, right? Is this part clear?
Yes, sir.
So this will move along the parabolic path, right? So this is velocity of truck. This is velocity of stone. So if we calculate velocity of stone relative to this truck, this would be Vs minus Vt, right? So this would be minus of Vt and then the stone will go in this time. So did you understand this part? Clear?
Yes, sir.
Just note down this diagram and then right. So now what is the next question? A train is traveling along a horizontal rail at the rate of 90 kilometers per hour and rain driven by wind blowing in the direction of motion falls at a velocity of 12.5 meter per second, making an angle 30 degrees to the water. Find the velocity of rain as seen from the train, right? So we have to find out the velocity of rain with respect to train. This we have to find out, right, Rishita? Clear?
Yes, sir.
Which means that we have to find out velocity of rain minus of velocity of train. This we have to find. So let us make the diagram and then that would be easy. So a train is along a horizontal rail at a rate of 90 kilometers per hour. So let's say that the train is moving in this direction. This is the velocity of the train. Okay, and this is 90 kilometers per hour. And this is the magnitude, so 90 kilometers per hour. And then we have this velocity of rain. This is 12.5 meter per second. So these are two different units, so we have to make them in a proper unit, right? So this would be 12.5. And if I want to change meter to kilometer, so then I have to divide by 1000. Right? And I have to change the second to hours. So then I have to divide it. This is in the denominator, so I have to divide it by 3600. So this will come in the numerator. So this will cancel out. This is 5. This is 80. This is 2, and this is 0.5. So this is how much? 90, 36, and 9, 45. So 45 kilometers per hour. So we have a train which is moving with 90 kilometers per hour. and then the direction of train. In the direction of train, the rain are falling vertical. So this is how the rains are falling, right? So, and they are making an angle 30-degree with the vertical. So this is the velocity of the ray, right? If I draw it in proper way, so this is the velocity of the ray with 45 kilometers per hour. Okay. Now find the velocity of train as seen by. So we have to find out VR, right? So this is VR and this is VT. So we have to elongate this V in the opposite direction. So this is my VT. Let me write it in that proper colors. This is my minus of right. This is my VT. This is my VR, and then I have to take the resultant of these two. Right. So that would give me the relative velocity. So I have to make a parallel line to this one and then parallel line to this one. So this would be my VR. Is this part clear? Is this part clear?
Yes, sir.
Okay. So now we have, now these are not perpendicular, right? So in the earlier case, we used to get this kind of figure. But now our figure is what? So you see that I have two vectors, this one and this one. These are the two vectors, right? And the angle between these two vectors is how much? This is 30, right? So this would be how much? This would be how much, Rishita?
60.
60, right? And then this is 60, which means that this angle would be 120, right?
Yes, sir.
So this is the angle between two vectors. Angle between VT and VR is 120. So then we have to find out the resultant. Now what is the resultant? So VRT resultant would be VR square plus VT square plus 2VR VT and cos of 120. Correct?
Yes, sir.
So VR is how much? VR is 45. So 45 square and then this is 90 square. 2 into 45 into 90 and cos 20 is cos 90 plus 30, right? So how much is cos 90 plus 30?
Cos
Cos
minus cos 30
minus this is 90, so that would be sine 30, right?
sine. Yeah, yes, sir.
Yes, absolutely. So good. So, right, this one here, so this is 90 plus theta, that is minus 90, right? If this would have been cos 180 minus theta, then that would be minus of cos theta, right? But this is 90, so then this would change. So now we have all these numbers and let us. So what is common? We can see that this is 45 into 45. This is 45, 45 into 2 into 2. And this is 2 into 45 into 45 into 2. This is minus of sine 30, right? So we can see that what is common? 45 is common in everywhere, right?
Yes, sir.
45 into 45 common. This is 1 plus 4 plus 2 into 2 into minus of sine 30 is half, right? So 2 will cancel. This would become 45 will come out of the root. This will become 1 plus 4 minus 2. So this is 45 root 3 kilometer per hour. This is the magnitude of the resultant, right? Understood?
Yes, sir.
And the answer is in meter per second. So we can again check or change it to meter per second. So 45 root 3 kilometer is 1000 meter and hour is 3600 meters. So this cancels, and this is 5, and this is 18. This is 9 twos are 9 fives. So 25 root 3 by 2. This is the answer, right? 25 root 5, 20 root 5 root 3. Oh, so we have 225 root 3. Now we have to find out what is the angle to the vertical away from train. Right. So this is the vertical, right? And what is the angle we have to also find out, right? We can find the angle by, yeah, so angle is how much? Tan of alpha. If we write, yeah, so this is the resultant, and this is the angle that we are trying to find out, right? So we have this one, we have this one, and we have this, right? So we know that opposite to, yeah, so how can we find the angle? So opposite to this one, we have whole this angle, right? Or or if we draw these triangles, how much is this is VR, and this is 30, right? And this angle we have to find out, right, Nishita? So angle we can,
Yes, sir.
yeah, angle we can find out by, so that is B sine theta divided by A plus B cos theta, right? This is the angle, right, Nishita? So
Yes,
this,
sir.
so this would be how much? B is yeah. So B is, let's say down this vector. Let me check, how do we calculate it? This this is BRT and this is theta. Okay, how should we get 60? So this is 30, so this should be 60, right? So this should be 60, but we have to calculate this one problem. This is a very long question, so let us find out. So B is So how do we do that? Incline at an angle of 60 degrees to the vertical away from our train motion. This is the train motion, and this is the vertical away from the train motion, right? And this is 60 degrees, and this one is 30 degree vertical away from the train motion. So these two answer would be one of these two, right? So what should be that? Uh, we have yeah. Yes, Rishita, are you saying something?
Nothing, sir. I'm just looking at the problem.
Oh, you are noting it down.
No, no, I'm just looking at the problem.
Yeah, yeah. So let me draw this vector part clearly. Then this would be one. Have this vector Vt, and then this is Vr, right? The angle between Vt and Vr is how much? So in this way, we can clearly. So this is 60, right? This is 60. Good. And we know from the triangles law, right? So this would be minus Vt, and this would be, so if I draw this one and this one, so this is my result, right? And this is exactly like this graph. So let's say we have this A, let's say we have this B, and then we find out what is VA minus V, right? So then that is equal to, okay, so this is our A, and this is our A, and this is our B, right? So which means that VB is V is VT, and A is our VR, right? So which means that we can calculate the tan theta by B sine theta, which is VT sine theta. So 90, and sine of theta is 60, divided by A, which is 45, plus B, right? And cos of 60. So this is 90, and root 3 divided by 45 plus 90 into, this is how much? 1 by 2. So 45. So this is 90 root 3 by 90. So this is root 3. So then this would be 60 degrees. Correct? Is this clear? This was a
Yes,
very,
sir.
yeah, so this was a very complicated one.
Lengthy question.
Yeah, this was a lengthy question, right? We have to figure out what is B and what is A, right? Okay, so this part would be not in the innate part, right? This would be JEE question, not. So please note it down, right? And yeah, did you understand this part? So I made this complicated, but yeah, I will also try to make it easy, right? I will think of a way. So firstly, I was thinking about this rule, right? So this one is the standard rule that we, but we have this rule also, that if we know this resultant, if we know this A, if we know this B, and this is theta, this is alpha, this is beta. So sine rule we know, right? R by sine theta and A by sine alpha and B by sine beta. So I was thinking about this rule to apply because this is B, but I couldn't figure it out, so I will think about it. But this method we can. Okay. So please note it down, Rishita, and yeah, please note it down. And you also
Okay.
think about, yeah, also think about this question at what should we do? We will stop at this point, right? Because nobody is here, and if we do any other problem, then yeah, yeah. Yeah. So whenever you need me to scroll down, please tell. Yes, Rishita noted up to this point.
Yes, sir. Can you scroll down?
This diagram is important, right? So remember only these are the vectors R, T, and this one. Then we have to write the resultant of that.
Yes, sir. So can you scroll down? Sir, can you scroll up?
Down.
Yes, sir, I'm done.
Good. So what we'll do is that because nobody is here, right? And these problem, river crossing, and then yeah, a person walks at the rate of rain appears to be particular at the rate of find the magnitude and direction of two velocity of the light. Yeah. So these question, uh, wind is blowing, a man wishes to cross. All these questions, right? So these we have to. So this we will do in the next class, right? So, we have to talk about first. I will do this river crossing problem. So in this river crossing problem, we will have three scenarios. Right. So one would be that we have this river, and the so this is how the flow of right, and then there would be this swimmer, so who will try to just cross this bank, right? So then when this man will move with this velocity, right? But due to the resultant, it will move in this direction because this is the velocity of this stream or river, and this is the velocity of the main. So then he will go in this direction. Whenever man moves with this velocity, right? So he will be deviated or drifted in this direction. So this we will do, and then there would be this shortest path, right? So to save from this drifting, the man will move in this direction, right? So if the man move in this direction, then the resultant would be this one, right? So all these things we will do in the next class. Okay, so this is the shortest path because for this case, the man will follow this path. So this is the velocity of the man with respect to river, right? In the earlier cases, for the case of relative velocity, when we calculated this man with river, so then we'll have to take this one, right? But for the case of river crossing problem, we don't calculate the result. Okay, we don't calculate the relative. So we calculate the resultant.